Hi ladies, this is Mrs. Blaufuss again. This is lesson 3.3 and it's about constructing perpendiculars to a line. So last lesson, lesson 3.2, we constructed perpendicular bisectors. So we were given a line and then we chose 2 points that were on the perpendicular bisector in order to construct our actual perpendicular bisector to the line. Here we're going to work in reverse a little bit, and so we're going to have a point, and then we have to find the endpoints of the line, and then we can construct our perpendicular bisector. So the first step here, first thing we're going to do is we're going to construct perpendiculars to a line. So it first says that we need to draw a line, and we need to draw point P that is not on our line. So it doesn't matter where you draw point P, but just somewhere, and label it so that it's not on your line. The next step is to label points A and B on the segment so that they're equidistant from point P, or actually it says that this is a line. So really this should have arrows on it. So it says to label points A and B so that they're equidistant from point P. So in order to do that, we're going to use our compass. And we're going to set it just so that somewhere our compass, an arc that we draw, intersects with our line. Okay, so here are my 2 points, and I'm going to label them A and B. Here's A, and here's B. So those 2 points are equidistant from point P. Now the next step says that we're going to use the converse of the perpendicular bisector conjecture, and it asks us, how is PA related to PB? So if I were to think of PA and PB as little segments, PA here and PB here, how are those two related? Well, you might actually be able to see that they look like they might be congruent, but let's go back to our theorem, our conjecture, and see what that says. It says if a point is equidistant from the endpoints of the segment, then it should say it is on the perpendicular bisector of a segment. So if a point is equidistant from the endpoints of the segment, which point P is equidistant from A and B, then it is on the perpendicular bisector of a segment. So we're going to use that equidistant. That's our key term here. Equidistant. That means equal distance. So we can say that PA is congruent to PB because of this key term, equidistant. So our next step is to construct the perpendicular bisector of AB and label the midpoint M. Alright, so we have one point that's equidistant from AB. Now we just need another point. So it doesn't really matter what your compass setting is as long as it's at least halfway between A and B. So I'm just going to modify mine a little bit. And it can't be the same point as P. We already have that point. We need another point to form a line. So there's my first arc. That arc is equidistant. Every point on that arc is equidistant from A. And here's my second arc. And now every point on this arc is going to be equidistant from B. So where those 2 points intersect, they are both equidistant from A and B. that point right there is equidistant from A and B, and P is also equidistant from A and B. So therefore, that point right there and point P form my bisector. And you can use your bisector either as a segment or a line, but really it could go on forever. And then it says label the midpoint M. So now let's label that point right here, M. And you can always, anytime you're constructing, just leave your markings on there so that it's easy to see that you actually constructed it, rather than just drawing it, but somehow distinguish between what you're actually doing. So like the perpendicular bisector, maybe like make it a different color, or highlight it, or make it nice and bold or something, so that we can actually see when we're going over your work what you actually did with all of that construction. And then the next part is to label 3 randomly placed points on A, B as Q, R, and S. Measure PQ, PR, and PS, and PM with your ruler, and which one is the shortest. To make mine a little bit bigger so that you could see a little more easily, but we're going to mark those 3 random points. So we'll call this point Q, we'll call this point R, and we'll call this point S. So Q, R, and S. And so now we should take out our ruler, and we're going to measure between PQ, and I'm just going to make these lines purple just so that I can see them. So PQ we're going to measure. We're going to measure PR, and we're going to measure PS, and we're going to measure PM. And we want to see which one is the shortest. So take out your ruler. I'm going to use centimeters, but you can use inches or centimeters, whichever is more appropriate for your diagram. Okay, so I'm going to start with PS, and that's about 5.25 centimeters. Okay, now my next one, I'm going to measure PR. And PR is about 5 centimeters. I'm going to go back and I'm going to measure PM. And that's about 4.75 centimeters. So if you notice, they're getting smaller. And then my last one, PQ, that is about 5 centimeters, about the same as PR. Okay, so they started getting smaller, but then as soon as I passed PM, PQ is larger. So the closer my point is to the perpendicular bisector of my segment, the shorter the distance. So we can use that information now to form our next conjecture. And our next conjecture is the shortest distance conjecture. So the shortest distance from a point to a line is measured along the perpendicular segment. From the point to the line. So going forward, we're going to just refer to this as the distance from a point to a line, not necessarily the shortest distance from a point to the line. So we'll say that the distance from a point to a line is the length of the perpendicular segment from a point to a line. So this is what we're going to use to measure our altitude. So the altitude of a triangle is the perpendicular segment from the vertex to this opposite side. Or this could also, sometimes it doesn't reach that far, the segment doesn't actually reach that far. So it could also be, instead of just from a vertex to the opposite side, or perpendicular segment from the vertex, from a vertex to a line containing the opposite side. So, for example, this is an acute triangle. So this actually on your note sheet should say an altitude can be inside the triangle. So make that correction, please, on your note sheet. An altitude can be inside a triangle. So here, this is an altitude. It comes from the vertex, and it's perpendicular to the opposite side. Here's another one. It comes from the vertex, and I'm just going to kind of estimate here, but it's perpendicular to the opposite side. And here comes from the vertex, and it's perpendicular from the opposite side. So all three within acute, all three of those altitude measures are inside the triangle. Now the second one, this is an obtuse triangle. And so notice that this first altitude measure that they show you, that is not inside the triangle, but they had to extend this segment here. So this would be a line containing the side. So if this were a line and it went on forever, it contains that side. And the altitude would be from this vertex perpendicular to the line containing that side. So this is an obtuse triangle. And we'll look at all the altitudes, but it has, this first altitude is outside of the triangle. The second one is inside the triangle. And then this third one, we would have to, again, extend this line of the triangle out here so that when we measure the altitude from this vertex, we could meet it at a 90-degree angle. So with the obtuse triangle, we have two altitudes outside and one altitude inside. And then the last one, this is a right triangle. And so two of the altitudes are actually the sides. So from this vertex, perpendicular to the opposite side here, that actually is one of the sides of the triangle. And from this vertex, perpendicular to the opposite side, that also is one of the sides of the triangle. And then the third one would be this vertex, perpendicular to the opposite side. And that one happens to be inside the triangle. So with the right triangle, we have two altitudes, our sides, and one altitude is inside the triangle. So that's all of lesson 3.3. So please jot down any notes that you have, and then when you come back and I see you in class, we can go over any questions that you had on this lesson. Thanks, ladies.